Hi everyone, welcome to my channel. We talked about matrices multiplication in the last video, after which you may still have some question marks in your mind. We've learned that matrices multiplication is not commutative, which means A times B does not equal to B times A. I know you have a question mark here. We also said that the column number of A needs to be equal to the row number of B in order to perform the multiplication. This could be where your second question mark is. Furthermore, we concluded that the result matrix C of A times B has the same row number with A and the same column number with B. You may ask why here as well. So, why do we need matrices multiplication? And why does it has those three characteristics? Today's video aims to help you find out the answers to these questions. To answer the questions, we need to trace back to linear equation system. Suppose we have to solve a linear system with two unknowns x1 and x2. Let A be the coefficient matrix of the linear system. Let's consider a more complex scenario in which what we want to find are not the possible values of x1 and x2, but instead some y1 and y2, which are the unknowns of another linear system that has x1 and x2 on the right-hand side of the equations. We can use B to represent the coefficient matrix of this linear system. It's clear that we can solve linear system 1 and then solve linear system 2. However, can we find a way to solve the two linear systems as a whole? By substituting linear system 2 into linear system 1, we can get a new integrated linear system. Then we just need to solve the new integrated linear system. We let C be its coefficient matrix. Let's observe the first row, first column entry of C, which equals to A11, B11 plus A12, B21. Recall the concept of dot product that we mentioned in the last video. This is exactly the dot product of vector A11, A12, and the vector B11, B21, which are the first row vector of A and the first column vector of B, respectively. You can possibly get some clue here that C equals to A times B, and that the ith row, jth column entry of C is the dot product of the ith row vector of A and the jth column vector of B. Then we can verify whether it is the same for C's other entries. Let's verify this by looking at the other entries of C. Let's check it one by one. We have already verified the first row, first column entry of C. So let's jump to the next one. The first row, second column entry of C is the dot product of the first row vector of A and the second column vector of B. The second row, first column entry of C is the dot product of the second row vector of A and the first column vector of B. And the second row, second column entry of C is the dot product of the second row vector of A and the second column vector of B as well. So, yes, this has verified that the ij entry of C is the dot product of the ith row vector of A and the jth column vector of B, and C equals to A times B. In other words, matrices multiplication can be thought as plugging one linear system into another. Let's expand this to a more general example. We have a linear system with j unknowns from x1 to xj, and I equations with c1 to ci as the values on the right-hand side of the equations. Similarly, we have another linear system with k unknowns from y1 to yk, and j equations with x1 to xj as the values on the right-hand side of the equations in the system. Let A be the coefficient matrix of the first linear system, and B be the coefficient matrix of the second linear system. A has I rows, j columns, and j is the number of unknowns in the first linear system. Because of this, the second linear system must have j equations, since we need the j unknowns in the first linear system to be the combinations of the unknowns in the second linear system. This is exactly why the column number of A needs to be equal to the row number of B when multiplying A to B. Also, because the ij entry in the result matrix C is just the dot product of the ith row vector of A and the jth column vector of B, we know that the matrix C must have I rows and j columns, which are equal to the row number of A and column number of B, respectively. This is the end of today's video. Thanks for watching. Hope you don't have any question marks in your mind regarding matrices multiplication now. Please like my video and subscribe to my channel if it helps you. See you in the next video.